The given numerical is a 100 microampere ammeter has an internal resistance of 100 ohms. For extending its range to measure 500 microamperes, the shunt resistance required is of. It is asked in GATE 2001, and here are the options. So first of all, see what is given in this numerical. Here one ammeter is given whose range is given as, that is the 100 microamperes, and internal resistance. Every meter has its internal resistance. So the internal resistance of that ammeter is given as the 100 ohms. And what is asking, that is when we extend the range of this ammeter from 100 to 500 microamperes, in that case what value of the resistance, that is nothing but the shunt resistance, we have to connect, so that the meter will now give, or its the range of that meter now increase up to 500 microamperes. So first of all, see the diagram. This is nothing but the diagram. Here you can see, when only this ammeter is connected in this network, then the ammeter current is given as, that is nothing but your 100 microamperes, and the meter resistance, that is the internal resistance of that meter, that is Rm, is given, that is the 100 ohms. And if we want to measure now, or if we want to extend the range now from 100 microamperes to 500 microamperes, then what should be the value of this shunt resistance? We have to find out. We know that this type of numerical is related to the PMMC instrument, that is nothing but the permanent magnet moving coil instrument. When PMMC used as an ammeter, and if we want to increase its range or extend its range, in that case this is helpful, or this is the diagram, you can see it. So here you can see, when we want to increase or extend the range of this ammeter, in that case we have to connect one resistance in parallel with this ammeter, that is nothing but the shunt resistance, and which is denoted by RSH. Now in this case, if we increase this value of current from 100 to 500, that is nothing but, now we have to measure the current, that is nothing but the 500 microamperes, that is the capital I. In that case, what should be the value of this shunt resistance? We have to find out. So the given data is, that is the internal resistance of the meter 100 ohms, meter current, that is the 100 microamperes only when ammeter is connected, and if we want to increase its range, that means now we have to measure from 100 to 500. So the total current, that is the circuit current, that is the capital I, is nothing but the 500 microamperes, and we have to find out the shunt resistance, that is the RSH. So we know that the formula for finding the shunt resistance is given as Rm divided by M minus 1. This is the formula. When we have to derive it, that means this formula, it is nothing but the derivation of that complete network, and from that derivation you can have this formula, that is the shunt value of the resistance is given as Rm, that is nothing but the meter resistance, divided by M minus 1, where this M is nothing but the multiplying factor, and it is given as the formula, that is the I divided by Im, where I is nothing but the total current of that complete network or the circuit, and Im is nothing but the meter resistance. Now simple, here first of all find out the value of this multiplying factor, because this is unknown. We know the value of Rm, which is given in the numerical. Now for finding this multiplying factor, this is the formula to find out the multiplying factor. Now here substitute the value of I and Im. So after substituting the value of the currents, that is the circuit current I and the meter current Im, we will get the value of the multiplying factor, that is nothing but the 5. So the value of M is 5. Now substitute this value into in the equation number 1, that is nothing but the formula of the RSH, that is Rm upon M minus 1. After substituting the value, we will get the value of the shunt resistance, that is the 25 ohms. That means when we connect the shunt resistance of 25 ohms in parallel with that ammeter, in that case only the meter value or the range of that ammeter will extend from 100 microamperes to 500 microamperes. So from the given options, the correct answer is option number C, that is nothing but the 25 ohms.